Okay, now it's time for a standard algorithm with a one-digit divisor. I'm using the same numbers I did for our partial quotients with a one-digit divisor because I want you to see which one is more efficient. So, standard algorithm we have our wrap. Divide, multiply, then subtract, bring it on down, and bring it on back. So the very first step is divide. How many times can 5 go into 2? None. So I move on to my next digit, making this 28. How many times can 5 go into 28? Now, if you don't know your facts, write them to the side. So say you can only get up to 10. Use your fingers. 11, 12, 13, 14, 15. There should be no reason why you get stuck if you don't know your facts. Use your fingers. You can do it. That's perfectly fine right now. All right. So 5 goes into 28. 1, 2, 3, 4, 5 times. Because if I did 30, that's too big. So there are 5 groups in 28. So our next part, divide, multiply, then subtract, bring it on down, and bring it on back. I divided, we gotta multiply. 5 times 5 is 25. Then subtract. Okay, so this was telling me what we already knew, that there were going to be 3 leftovers after I grouped my 5. So if I had 28 dashes, I would be able to make 5 groups of 5 with 3 left over. And the last step, divide, multiply, then subtract, bring it on down, and bring it on back. So start at the top, divide. How many times can 5 go into 30? Oh, well, it's right here. 1, 2, 3, 4, 5, 6. Multiply, 5 times 6. Then subtract. There's nothing to bring down, so we don't got to bring it on back. 0 is right here, which means we don't have a remainder. The answer is 56.